Hey y'all. Okay, so today's lesson is solving a system of equations by graphing. Just to review, a system of equations is a set of equations with the same unknown variables. Here are just some steps to make this go smoothly. You're going to want to put it in slope-intercept form, y equals mx plus b. We practiced this earlier, so I'm going to just review it quickly with you today. You're going to graph b and use m. So you start with b, you put a dot at b, and then you use the slope to count up and over. You're going to find the intersection of the lines, and then you're going to check your solution. So the intersection is going to possibly be your solution. So here is our first example we're going to do. I have one equation already in slope-intercept form, but this equation is in standard form, so I need to solve it to solve for y. So I'm going to subtract 2x from both sides, and then I get y equals negative 2x plus 6. And then sometimes you might have to divide by something, but now I'm done. So here is my equation in slope-intercept form. So I have my first equation up here, and then my second equation. And let me just go back and review. I had to move this term over so I don't divide because it's being added to the y. I just subtract 2x from both sides, and I can't put these together because they're not like terms. So I have two equations. Now I'm going to show you how to solve by graphing. Okay, whoops. Okay, so, well, here we go. Example 2. I don't know what happened to example 1. Example 2. I have an equation and they're both in y equals. So I need to graph them. And remember, you start with the b and then you use your slope. For this one, the b is 3. So I'm going to count up 3, because remember, that's your y-intercept. And then I'm going to use the slope. The slope is negative 1, which means negative 1 over 1. I want a negative line, so I need to go this way. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, and then I'm going to connect. Whoops. Okay. That's not a good one. And hopefully yours is better. So I've graphed my first line. That's the first line. Now I need to graph the second line. The second line is y equals 2. That is the y-intercept. That is the b. So I need to count up 2. But there's no slope in this equation, so that means the slope is 0. A 0 slope means a horizontal line. So I'm just going to go across like this. And that is the other graph. Whenever you have x equals just a number when you have y equals just a number with no x, it's going to be a horizontal line. You should see where these two lines intersect. It's right here. That is step 3, find the intersection. This intersection is the solution to our system of equations. This is the dot, I guess, over 1 up 2. Because I went over 1 and then up 2. So this is the coordinate that we're saying is our solution. That is the intersection. But we always want to check it. So to check it, you plug it in. Right here, let's plug it into y equals negative x plus 3. If I plug in a 1 for x and a 2 for y, is this sentence true? Negative 1 plus 3 is 2, and 2 equals 2, yes. So it works for the top one. Now let's check it for this one. Y equals 2. Well, my y value is 2, and 2 equals 2, so it checks out. So the solution is 1, 2. That is the answer. That is the solution to this system of equations. Oh, here's example 1. Sorry. All right, well, whatever. We have two equations. Y equals a 1/2 x plus 1. And the one from before. 2x plus y equals 6. But we already rewrote it as y equals negative 2x plus 6. So here are my two equations, equation A and equation B. I need to graph them, so I'm going to graph A first. This is where I start my B value. So I'm going to put a dot at 1. And I have to use my slope of 1/2. That's rise over run. and it's a positive. So that means I'm going to go up 1 over 2, up 1 over 2, or you could go down 1 and over 2, down 1 and over 1, 2. And you should see the line that I have graphed for my first equation. Now the second equation has a y-intercept at 6, 1, 2, 3, 4, 5, 6. And it has a slope of -2. That slope of -2 is -2 over 1. So I want a negative slope. So I'm going to go down 2 over 1, down 2 over 1, down 2 over 1. And then you can see my intersection of the two lines is this dot right here. And it looks like that coordinate is over 2, up 2. So I found my intersection. That's where the lines intersect, and that would be my solution. Now you would test it and make sure it worked in your equations, but for sake of time, I know that it does. So here's your solution to the system of equations. All right, now special examples. We talked in class about there's a possibility for no solutions or infinitely many. So I'm just going to show you what that might look like. For this example, I have y equals -2x plus 6 again, but then I need to convert this one. So I'm going to subtract 2x on both sides, and I get y equals -2x plus 6. Do you notice anything between the two equations? If you notice, whoa, those are the same exact equations, then you should be kind of thinking, that's going to be different. If you have the same exact equations, when you graph them, they're going to be the same line. Because the y-intercept is 6, and then the slope is -2 over 1. So I go down 2 over 1, down 2 over 1, down 2 over 1. And let's see, down 2 over 1, down 2 over 1, down 2 over 1, right there. And you can see the line that I've created. If I wanted to graph this one, it would be the same line. I would graph over the line that I've already made. So because I have the same line, this is infinitely many solutions. When you have the same line, you have infinitely many solutions. Now in example 4, I have one equation in slope-intercept form, but I need to convert this one. So I'm going to add 3x to both sides, and I'm going to get 4y equals 3x plus 4. Then, I can't have 4y, I need to just have regular y, so I'm going to divide by 4. And my final answer is going to be y equals 3/4 x. 4 divided by 4 is 1. So 3/4 x plus 1. So here's an equation A, and here's an equation B. Do you notice anything about equation A and equation B? You should notice, the slopes are the same, but the y-intercepts are different. So let me show you what that means for our lines. If I'm going to graph this top one, I put a dot at 1, and then the slope is 3/4, so that means rise 3 over 4. So I'm going to rise 3, 1, 2, 3, 4. 1, 2, 3, and then I'm going to go over 4. 1, 2, 3, 4. So that was the top equation. This equation has a y-intercept of -6. So I have to go 1, 2, 3, 4, 5, 6. I got to put a dot down here. And then my slope is 3/4, so that means I'm going to rise 3 and run 4. So I'm going to go 1, 2, 3, 1, 2, 3, 4. And I realize that my lines are not perfect, but you should see that these two lines are what we call parallel. They're parallel lines, meaning they never intersect. They go run beside each other like railroad tracks. They never are going to cross. So if you have two lines that never intersect, that means there is no solution when you have parallel lines. So I've shown you how to graph and find the intersection. I've also shown you what it's going to look like if you have infinitely many or no solutions. And then in summary, here's just a summary page, but I also am going to show you how to do this in the calculator.